What's up guys, Rishi here. Welcome to the podcast. Today our guest is Logan Velvindron. He is an engineer at Afrinic, the Internet Number Registry for Africa. In this podcast, we cover web security elements such as TLS1.3 and DOH.
Yes, hi Rishi, I confirm that we are all in a hackathon right now for the IETF 103. We cover a range of different technologies right now. Part of it is about security. For example, there's a lot of work right now going on with TLS1.3, which is the next generation successor to TLS1.2. There's also work going on with HTTP 451, which is not exactly related to security. It's more about legal requests on the internet. For example, if you have a government that wants to, let's say, block a specific page, you don't need to block the whole website. You can have a specific page blocked. So that's why the the status code HTTP 451 was used. And then you have a third group, which is working on SSH. So when we think about SSH, we tend to think about the command line utility that everybody uses, but it's much larger than this because you have libraries that are built around the SSH protocol. So for example, you've got all kinds of Java libraries, for example, doing SSH. So SSH is similar to TLS in that it's about protecting information that's going from one endpoint to another endpoint, but the design is different. So in terms of SSH, it's more about securely connecting to specific endpoints, whereas in the case of TLS, it's more like trusting certain hosts on the internet. So SSH is used, for example, mostly for remote management. So you have all kinds of devices on the network, and SSH allows you to securely remotely manage it.
Got it. Thank you, Logan. Let's talk a bit about TLS 1.3. It is a major update in the sense that it is faster and more secure than its previous versions. You've been working on TLS 1.3. Can you tell us a bit about that?
So basically, TLS 1.3 is an improvement over previous version of TLS because it offers a number of privacy options that are not found in previous version of TLS, and also it's faster because it requires less round trip to establish a connection. So the whole team has worked on TLS 1.3 support on software such as wget, curl, it, Nagios, SOCAT.
Just to give a little context to the audience, wget is a computer program that retrieves content from web servers using HTTP or FTP. On the other hand, curl is a computer program which provides a library and command line tool for transferring data using various protocols. Also, Git is a version control system which allows you to collaborate with people online. Finally, SOCAT is a command line based utility which establishes two bidirectional byte stream and transfer data between them. Logan and his team at Cyberstorm.mu made sure that TLS 1.3 is compatible with those networking softwares. Moving on, I found that with TLS, the support for previous mechanisms such as MD5 and SHA-hash functions have been dropped because these were outdated.
Yes, correct. So those are mostly used for signatures, like cryptographic signatures. Basically, they are basically hashes. And the problem is that hashes are supposed to be unique, and when you have one way of generating the same hash with two different inputs, then this causes a number of issues. So that's why they needed to be deprecated.
Okay, that's good. And they have added support for modern algorithms such as SHA-20, Poly 1305, Stream Cipher. I am reading from my notes here. I see that there's quite a lot of new features.
Yes, the field of cryptographic and mathematics is continuously evolving. So as weaknesses are found, researchers are looking at new cryptographic algorithms and new theories that can be used to make stronger crypto. And one of them is SHA-20 and
yes, there's SHA-20, there's also RSA SSA/PSS signature algorithm. There are some modern crypto algorithms making the web a lot more secure now.
Yes, correct.
Getting back to TLS1.3. TLS1.3 is much faster because there's a new handshake model. There's a fewer round trips. In fact, there's only one round trip. Do you know a bit about that, the new handshake model?
Yes, so by default, TLS 1.3 works in what we call one RTT, meaning that there's still some handshaking involved, but what it does, it compresses. So you have larger TLS messages. So instead of having, for example, the client hello and then the server hello and then another port for the keys, and then another set of round trip for the keys, everything is included in the first client hello. So also the pre-shared keys is included, and when the server replies to you, it replies with a server hello as well as the pre-shared key. So you have bigger TLS messages, but the advantage is that you send less information per round trip. What you're talking about is quite specific. So it's called zero RTT. By making a few, let's say, by making the TLS connection a bit less secure, you basically save on the time that you need each time you have to establish a handshake. So it's called early data, but right now there are still ongoing research about the security impact of it in terms of real world deployment out there. So zero RTT right now is nice, but not that many organizations deploy.
We were also talking about DNS over HTTPS. This is also my favorite part. So I read a bit about it. I found that it is a protocol. It is being performed for DNS resolutions via HTTPS protocol. So can you tell us a bit about DOH, DNS over HTTPS?
So DNS over HTTPS was not quite designed by DNS architect. So in terms of DNS engineering group, it's quite a controversial standard, DOH. The reason why DOH came into existence is that despite the fact that we have a lot of new technologies out there, for example, for doing DNS over TLS, you only get it in the latest version of Android. So you only get DNS over TLS in Android 9. And Android 9 has less than 20% of the market share. So you've got all of those people running older versions of Android, but you have no way to really secure their DNS, because when you visit a website such as, let's say, www.wikileaks.org or www.yourfavoritepoliticalparty.com, so someone snooping in can see, by looking at your DNS traffic, can infer where you're going. So it's increasingly a privacy concern for a lot of people. So the idea there is a bunch of browser makers such as Firefox got together working with providers such as Cloudflare. And what they are doing, they came us with DOH, which is DNS over HTTPS. Instead of doing the DNS at the systems level, the DNS resolver process at the system level, we do it within the browser itself. Essentially what happens in the latest version of Firefox, you have the option of pushing your traffic, your DNS traffic, over an HTTP. When you do that, it works. When there is some performance penalty, it's not that big, but for privacy concern, people consider the performance penalty to be acceptable. The problem with it is that it raises a number of issues. Most people, they don't know where their DNS traffic is going. They assume it's going to the ISP. And the ISP is used to seeing your DNS traffic. In fact, there's a whole market out there of monetizing DNS traffic. So previously, the money that was going in through ISPs by monetizing the DNS traffic could not be going there. So it could be going to a CDN provider. And this is causing a lot of friction. So it's not only a technical debate, it's also about a
business debate. It's a bit about
business. Correct. A business debate. And
due to an internet connectivity issue, Logan could not be heard properly, so I'm going to clarify what he meant in the next minutes. Logan continued by explaining how tracking of users' web history via DNS can pose a legal issue based on GDPR for Europe and the Data Protection Act for Mauritius. Next, Logan was asked about his most used websites. He replied, ietf.org and /. IETF stands for the Internet Engineering Task Force. It is an open standard organization which develops and promotes voluntary Internet standards. In particular, the standards that comprise the Internet Protocol suite. It has no formal membership or membership requirements. At ietf.org, you can find about automated network management, Internet of Things, new transport technology, and much more. Logan uses the website to find out new networking innovations. Logan uses /.org for technology and open source related articles. Both of those websites are linked in the description, along with a link to cyberstorm.mu, where you can find more about Logan and his team.